guys? Very excited. All right, so we're talking about graphing. We're starting with logs. So log functions are the inverse of the exponential function. So what do you guys remember about graphing logs? I'm interested actually. I can tell you all day. What do you guys remember?
It's the opposite of exponential.
It's not opposite, it's inverse. I think I know what you meant though.
And then instead of going, it goes like this on the asymptote. Like this,
Yep.
It goes like this.
So there's two things that happen. Instead of a horizontal asymptote, log functions are going to have a vertical asymptote. So commonly, without any transformations, the vertical asymptote is at x equals 0. Good. Now, exponential functions, we focused on 0, 1. To do inverses, you swap x and y. So we're going to focus on 1, 0. Okay. So at this point, the basic function is going to look just like this. Now, we'll tackle how to do this in just a minute, but let's say this was log base 4 of x. What happens to the graph if the base increases? Like instead of 4, it's 6, or 8, or 10, or 20, or whatever. Does anybody know? Chris? Yeah. Anybody else got a different way to say that? Because I think I know what he's saying. What happens when the base goes up?
It becomes like wider.
Yeah, like once it gets to that point, it's just a sharper curve. Like it doesn't go up so gradually. So everything else is the same though until that point. So maybe this is log 6. Maybe that's log 8. So I just want, it doesn't really matter. I'm going to show you guys how to manage the base in a little bit. But basically it just gives you a little bit of context for how it's going to work. Okay. All right, start with that. So just write it down. That's what I mean by starting it. Write that down. Let's draw a graph.
Done.
My hair's like done, and then the gnats everywhere. Also, you know what's scarier than grasshoppers? Have you seen those grasshoppers flying around? They're gnats.
They're scary.
This grasshopper?
Plagues, guys.
The plague is literally.
You're the firstborn. You better be careful.
Like it's.
I'm not.
Oh, true. Pharaohs.
Depending on what you believe, you better put out Lamb's Blood X on your front door.
Remember the plagues?
Yeah.
Well, you know, I'm not.
It's a reference. It's a reference to how to. No, it's on it. Yeah. And then doing the.
Whoa.
But if you did it, I would do
The pharaoh.
Yeah, I guess that's. I guess.
I know.
I stay educated.
All right, guys. So the transformations. Who can just tell me in words what the transformations are going to do for this graph? Right.
Up to.
Up to.
Whoa.
And then the 2 in the front, it may stretch it out a little bit, but it doesn't really matter. We're going to figure that out in just a minute.
Times 2.
Yeah, all the things. Okay, good. So, much like we did with exponential functions, I want you to just start at 1, 0. We're not going to plot 1, 0. We're going to figure out where 1, 0 ends up. So what we normally would have done is we would multiply the y coordinate by this number. That was the first thing we would have done on Monday. But the one thing about logs is your y value is 0. So it doesn't really matter what that leading number is because it's not going to affect your y value at this current moment. So all we really have to do is move that coordinate to the right 1 and up 2. It shouldn't be too difficult. It's going to be at 2, 2. Oh, sorry, to the right. It's just a directional arrow. So we always keep track of 1, 0, and then we figure out based on the transformations, where does it end up? Kind of like what we did on Monday. But the thing about logs is you don't really have to worry about that a value. It doesn't really matter what it is.
Boom.
All right, so let's plot 2, 2. The vertical asymptote is going to be. Anybody know? No. X equals 1. Why do you say that? Yes. One of the properties of logs is the input can never be 0. It's undefined. It doesn't exist. So wherever that value is equal to 0, that's going to be your vertical asymptote. So it's just going to be right there. Yeah, because if this is going to be equal to 0 at 1, right? Another way to think about it, guys, is if the vertical asymptote was right here. When I shift it to the right, it's going to go that many units right or left. This is going to be how you determine where the vertical asymptote is. So if you just think about setting this equal to 0, that'll be where your asymptote is.
How do I just get the?
All right, this part is the only part that's different than what we did on Monday. So to find the other coordinate, I want to make sure it is a whole number coordinate, an integer coordinate. Usually we would have just picked one space to the right or one space to the left, but that's not enough. That's too simple. We need to pick a specific x value. And I don't know if you guys remember this property, so I'm just going to pose the question to you. What is the best x value to choose? What does it say? What time? Please report regarding French. Yeah, just go now. Anybody know? 2 is not a good choice. Well, it's a fine choice, but it's going to give you a decimal. If I pick a very specific number, I can guarantee to get a whole number. 3 is not the choice. 4 is the right choice. So I think maybe what you were getting at, Sean, is a property of logs. If the base matches your input, then the answer to this is 1. It's just a property of logs. So pick an x value that'll make the input match your base. If the base is 3, 4 minus 1 is going to give me 3, so that's why I'm going to pick x equals 4. I'm sorry, why did I write 4? So, what I'm going to do is I'm going to take that, 4 minus 1 plus 2. This is equal to 1. 1 times 2 is 2. 2 plus 2 is 4.
Wait, what?
Take a minute. If you got a question, ask it. How did I get, what's that?
Wait, can you explain the x equals 4?
Why did I choose this?
Yeah.
Yes, because a property of logs is if the base matches the input, it's equal to 1. So since the base is 3, I would prefer this input to be equal to 3. If that's the case, log base 3 of 3 is equal to 1. Now, what number plugging in here will give me 3? 4. 4 minus 1 is 3. So that's why I'm going to choose x equals 4 as my value. So, all we got to do is plot 4, 4. And there you go. You have your graph.
Yeah.
Oh wait, I see
Is
them.
there a code? Can you give me a code?
Questions? Braden, questions? Anything over here? It's okay? Makes sense? All right, I'll give you another one to try on your own then. Y equals negative log base 5 of x plus 3 minus 1. Give it a try, give it a try, give it a try.
What's up? Oh, yeah, they're. I don't know why, but they like this. None actually. None? I always wear one. Like, I don't bring an extra one. I probably should bring an extra one. Sometimes you like, I'm cold. Yeah, just then I have to go with mine. Oh. No, but I'm looking. There's like a fat center console in the middle.
A year from now.
And then like the back is so small.
I did this.
That's good. That's a good start.
Oh man. I think it's bigger car for that. Hey, you're looking at the dude? I saw that. Oh.
Yeah.
Why
So the value inside the parentheses, that's going to tell you left or right.
$7,000.
And then the coefficient on the end, that's going to tell you up or down.
I fill it up with $8 instead of like 80 or
Well, you left.
Actually, $8? And you can do that home run.
Yeah.
That's sick.
then we got a solar panels.
Well, you have a 0 would then go to,
No,
it'd
start
be
selling electricity back to the
-2, -1.
That is sick.
passive income.
Oh,
Because think, if you're at 1, 0,
dude, that is sick.
Wait, like, would you start here and then?
and then you go to the left 3, and down 1. So that changes.
Wait, so you
Pine
start
Ridge
out with
Reservation.
1, 0.
You would start there.
Well, you keep track of
Pine
it.
Ridge Reservation.
You don't actually plot 1, 0.
Oh, yeah, okay.
Yeah, it's where you start and then you do the transformation.
That's an AB.
So
What?
left 3 and down 1.
Oh, I'm thinking nuts, don't worry.
Mhm.
Oh, we're doing that one next?
Oh,
Yeah. 2, it should go like 3, 4.
that's what I was thinking.
So if you plug in 2, watch, so log 5 or 5 is 1. Then you have the negative in front. So it's -1 minus 1, so it'd be 2 negative 2.
Why did it do it? Didn't do it. This guy. He's intelligent. Why are you being intelligent? I don't know.
It's a braided show.
Yeah.
Late night.
Well, you always keep track of 1, 0. Yeah, you don't use it, you keep track of it. So you ask yourself, where does 1, 0 end up when you're doing all the transformations? Logs, yep. Exponentials would be 0, 1. Yep. Nice, good. Well, so that would be log base 5 and 5. That's equal to 5.
Oh, and that.
So then you gotta do all the other.
Like,
Put the negative in front, and then put -1. This portion is equal to 1.
Oh, I put base. Mr. Conley.
That is your y value. So it's 2, -2.
What's up? Okay, so for the question, this right? It goes up 2 because of this.
That, and
So-
then right 1 because of that.
So then this one would go left 3,
down 1.
Oh, that's sick. So
All right, guys. Vertical asymptote is at where, Sam? -3. All right, Reagan. 1, 0. Where does that end up? -2 what? -2. -1? Right? Okay. So then, -2, -1. All right, what's my best choice for the next coordinate, Thomas?
I think 2.
Very good, perfect. So, we select 2 as our x value, and we plug it in to find our y value. This is equal to 1. Then it becomes negative. Then you subtract 1 from it to get -2. So then 2, -2. And remember, if we didn't mention it right away, but if there's a negative in front, the graph is going to flip upside down. So that's why it comes along and goes like that. All right, graphing? You good with that?
wait a minute.
Do we need to do another one?
No. Okay, I did that. I need. Yeah, it's just you and that.
Okay, hold on.
Honestly, like yesterday I did all the math, but I don't want to do it. Wait, no, I remember. Oh.
That's
got it,
another
got it, got it.
coordinate. Yeah, that's another coordinate.
No, you're on the right path. It's still 3. It's still 3s. One more 3.
All right. So, along with logs, we're going to do something called evaluate
And then it's
a log.
what if you fraction?
So I'm going to give you a minute to think about this.
Okay, so I made a mistake.
The base number. Oh, 1, 0. Goes left 3.
I wish we could like
Yeah,
No, it's the black ass. You know?
All right. I'm interested. Does anybody know the answer to this? That's one number.
I can get it in my calculator.
That's good. I'll show you how to do that too.
The 9.
Not 9. Dalvin, what is it? It's 3. The answer is 3. All right.
I just tried.
So, if you were to be given this on Delta Math, all you do is type in the answer box the number 3. Now, why?
Because it's 1, 3, and 27, so
Yes, there we go. So there's a process that we are going to use quite frequently. I call it the Tarzan story. I don't know if that's
We're struggling.
I have a video of that. I was doing this. Yes, we have a video of that. Yeah, for like 3 weeks. She was like, and now
Hey, you never forgot it.
I actually did forget it.
Oh.
I know what that
Oh my god.
Log functions are tough for our mind to like. It's hard for us to wrap our mind around them. So what we do is we convert them into an equivalent exponential. So the process goes: you set it equal to x, and then you kind of swing over, grab that, and then swing back. So what I'm really trying to solve is 3 to what power is 27? And the answer is 3.
Now I'm gonna be too
This has to be the same as this. But it is right?
All right, real quick, I do want to show you one other thing.
I have footage.
Our calculators don't always do logs in base 3. Our calculators use log base 10. So there is something called the change of base formula, which you also could have used to evaluate this. You do the log of 27 divided by the log of 3. And there's no number here, so it's assumed to be 10. If you were to just type that into your calculator, you would get a result of 3. So there is 2 ways to do it depending on how you would like to do it.
It's blurry though. It's probably ended.
All right, I'm going to put a couple up here for you guys.
I love it.
the Nokia quality takes me out.
Why don't you go look again?
Oh. And she hits the trash. Go ah.
Wait, why'd you? Wait, she put something in. She had like voice back.
No, yeah, she always voice cracked when she came in. I guess
All right,
as you
give
get
those a
older,
try.
you go back to puberty, you have voice cracks again. What's
Wait a minute. No, I'm good. I'm good. Slithering like a snake.
I was wrong. I know somebody who like they're wonderful.
Honestly,
Yeah, like Edward, I think
I can't do it, man. I can't.
Wait, Mr. Corleone is the first one, I think.
Okay, just write it down.
Let me check my something.
Keep track.
because the first weekend he brought out the first weekend he brought out
I think I got it.
I was lost at that moment. I was like, yo, how far have we fallen?
No, he used Morgan soundtrack.
Okay, yeah.
Surgery.
You gave it right.
It's like some pressure.
The first one, yeah.
Okay, so it's
What do you do if the pressure is negative?
I don't know about that next one. 16 to the 16th power? That's it.
It was definitely more like a Friday.
I'm asking you, 16 squared, 256? Oh, okay, I didn't think about it that way. That's why I asked you. That's what it seems like everybody else. I have no problems getting
Let's go, let's do it.
All right, hold on.
oh, it's
Yes.
Seems crazy.
I did them all.
That man must have been practicing.
So, I don't know if I have a non-calculated version of this test.
Because a negative exponent makes it a fraction.
All right, guys, so let's take a look. For this one, you would do 5 to the x equals 1 over 125. So if you wanted to, if you can't think about that right away, what you would hopefully realize is that 125 is 5 to the 3rd. So if I wanted to do the same base, 1 over 125 would be 5 to the negative 3 power. Once the bases are the same, like Monday, You set the exponents equal to each other and you're done. Because it wants to fraction. Always keep an eye out for a fraction. If you're doing these problems and you get a fraction, that means the exponent has to be negative in some way, shape, or form. Now this one, 1/8 to the x power equals 1/64. Since they're both fractions, most of you realize 8 times 8 is 64, so if you just square it, you're good. And there you go, x is equal to 2. This one, 16 to what power is 1/256? Go ahead.
-2.
Yep, because this one would be 16 to the x power, and this would be 16 to the -2 power. And so you get -2.
We're gonna get a calculator on this test, right?
I don't know. You might not.
Don't be
Why not?
You might not. I don't know. I need to go back and look.
Might not need one or might not be allowed one.
Huh?
Might not need a calculator or might not be allowed one.
Well, if it's not allowed, that means you don't need it. That would be kind of messed up for me to make you need a calculator and then not let you have it.
Wait, but I need a calculator to like check like what 2 plus 3 equals.
Yeah, I know.
Yeah, I literally jumped it out of my brain. I forgot to put it.
Yeah, we'll see. I don't know. I'll just go back and look at it.
Mr. Conley,
Like, if you said 2 plus 3, I
Can-
would
can I
write
take a
it
call
out,
outside?
and I'm like, do my
Yeah, man, go ahead.
phone.
with the exponent
Two
variable
plus
that
three.
No!
Man, I hope so.
Oh, this isn't, you're impossible.
That's why I didn't want to. 5.
Alright.
Logs.
We're going to wrap this thing up. We're going to talk about expanding and condensing logs. It should be relatively easy. Yeah. In order to do that, there's a handful of properties we need to remember. The first one is kind of one we already tackled. If the base of your log function and the input are the same, that is equal to 1. Okay, then we tackled, I mentioned it, but I really want to write it down. Your input for your log function can never be 0, or negative for that matter. It's impossible. So this would be undefined. All right, those two properties are pretty important. We're going to use those on Friday.
My handles.
All right, so this third property is called the power property. And basically all it says, if you have a log function, base 3, 5, 7, 9, 100, if you have something inside that has an exponent, you put it into the front. 2 log base 3 of x.
And then what do you do? And then you just put it in your calculator?
Well, no. When we do expanding and condensing, you're not actually typing something into your calculator currently. You're just kind of expanding it to then use to solve it in the future. That's true. Yeah, you're just reformatting. Very good.
I'm walking upstairs and I'm like, my name is there.
No, we don't really have a standard form and there's no graphic form, standard form for log functions. It's just equivalent versions of. All right. Then you have the product property. Product mean multiplying. So if you have a log, and on the inside is say something like x times y. Go ahead. Very good. That is equivalent to log base 3 of x plus log base 3 of y.
Oh, I can do that.
Yeah, that's all we're going to be doing for now.
Oh, okay.
On Friday, we're going to take it one step further. Control yourself.
I just remember this.
And then the last one was the quotient. Quotient property. Exactly. So if it was log base 3 of x divided by y, The division implies subtraction. So it would be log base 3 of x minus log base 3 of y.
And then it was like log x minus log y minus log z. Would it be x over?
It would be x over y 0. Whenever there's a minus in front of it, it's in the denominator. Whenever there's a plus in the front of it, it's in the numerator. Which we'll get to right now. All right. Let's jog your memory. All right, so we are going to condense.
I'm a chalk walk. Did you see all those people like they break?
It's okay, Kyle. I don't care.
It's like a
The Chocopalooza.
It's like today.
Like they're just like chalk, and just like I was like, I can't wait.
Chop, chop, chop.
I don't know why it's so scary.
How is it back here? That's what happens when you spend $180,000 on a college degree and get a desk like this.
It doesn't really seem like a fair trade.
Oh, what do you mean? It's easily worth that much. Look at this quality. Look at that.
Mr. Kyle,
That's hard oak right there.
Mr. Kyle, you gotta.
Look at that.
Mr. Kyle, you got another one of those?
No,
What if this is a C price?
for real, right there. Oh, you got any with these?
No,
This
no.
would actually be pills.
Cocktail.
I'd be like,
Looks like a.
Oh, those are RX ones.
Yeah, dude, I got them on sale.
Dude, so
Yo.
so
I only buy them when they're on sale.
so good.
That's the best
Yeah,
one.
that's
2 years ago.
Oh, yeah, Mr. Kyle,
was
my
just
test.
this-
I had two of those. Straight to it. What other ones?
And they took a drone shot.
I have a
I forgot how to do
bars.
logs. I like it. Logs are good.
class of 2025. We better do some
Those
logs.
are like bars.
And then what do you think?
It's kind of like a line sauce, right?
Mm-hmm, very good.
It has a lot of
I think,
Mhm.
you know what we should do? I read some
Why is it actually so like?
No, I want to see it.
Like how is it so?
Wait, was that?
Dude, I just reminded me, Kale reminded me of
I'm just
Jake.
like, how did you do like?
It has
I don't get how they did it. It's like nobody's coming up. And then-
All right, Braden, you ready? What do you do?
Oh, I didn't do anything. I'm just trying to figure it out.
All right, well, okay. This plus sign is going to be multiplication. So take this, put it as the exponent. Now this, let's take a quick minute to think about y to the 2/3 power. You can put that, yup, but it's the cube root of y squared. Okay, that's a way to convert from an exponential fractional exponent to a radical. Now, since there's subtraction here, that means there's a division symbol. And then on the bottom, we just put z to the 5th.
What is it?
I usually won't give you ones with the same base because there's literally nothing you can do. You can't use any of these properties unless the bases are the same. So if I gave it to you, you would just be like, that's it. I can't do anything. That'd be boring.
You should do that for the entire test. Yeah, you should do that on the test and then see who like
Who tries?
who tries and who is just like can't do it. Wait, don't worry.
Oh, sorry.
I'd probably try, but
Make sure you can find a template.
I would never.
and then maybe like, can I like do this?
Just take a picture of it real quick. Because I need the board space.
Yeah.
So there's just a property of fractional exponents. So this is fractional exponent, this is radical. This denominator is on the outside of your root. This numerator is on the inside of your root. It's just something we're gonna have to remember.
Wait, yeah, my allergies.
You don't
All right, on this next one, I'm going to give you one that people quite frequently mess up.
How many thingies are you doing?
Oh, I have to get some change in terms because people mess this up all the time. So give this one a try.
So I don't care. I'm gonna on those right. It's fine. No, I do it like so often. It's like kind of bad, but it works.
Those twos are key.
What?
The lot, you know, like next to the
Okay, I'm
Oh,
in.
mine. It's supposed to all be 2.
Okay, I'm sorry.
What is this?
The
So we're just
last one is a
condensing?
W, so
So,
it's
like, we got
X, Z, Y, and W.
properties right here? Or yeah, property.
I do it.
3, 4, 5.
In a minute, yeah. Let people think about it. Then you can do it.
They would just committed to use.
Give me a few minutes.
Then do.
Let's see, Josh.
You don't know how to do it. I was just
So
like,
you have
Look.
allergies.
You know what? I am blessed to not have allergies.
You're lucky. It's not fun.
I mean, what do you just get a stuffy nose?
Yeah, but then
Oh, yeah. Oh, I
My
get
friend
it.
Although I think I did have allergies as a kid to like pollen, but then I don't anymore. Maybe I grew out of it.
I have eyebrows. My dad had to take allergy shots because his allergies.
I don't know which base
He was allergic to like
That's the
everything.
whole Lord's
He
base
lived
too,
with
which is
allergy
base two.
and he had like 6 and
So the faction doesn't do anything, but it actually becomes the exponent.
My buddy does allergy treatments and they just like shoot him up with small doses of whatever he's allergic to. And then the next week they add more. That's what they do. That's why they say to give like because it used to be like if babies and stuff, you keep them away from like peanut butter, eggs, things that are like really high allergy. And now they say that's the first one. Yeah, like a small piece and see if there's a little bit of a reaction, and you just kind of keep going. But if it's big and stuff, what? Eggs are gross. Eggs are just so. They literally can go with almost anything.
Who eats eggs with ketchup?
Eggs is
Get out.
what?
Eggs with ketchup? That's disgusting. I mean, I know.
Alright, Jada, you ready?
salt and pepper only.
You gotta write it legibly. You're not the best legible
Can I write it for you?
Preposterous. What do you mean? That's not preposterous.
I can't understand.
Come on, Jada, you got this, Jada. Alright, let's see. Oh, I didn't trick him.
Got him.
There you go. Nice job. That wasn't bad.
That's what it is.
Alright, so the reason I gave you guys this one is sometimes people get confused about where the terms go. Alright, sometimes they'll put them in the bottom, sometimes put them in the top. Basically, if there's a subtraction, it goes in the denominator. If there's an addition, it goes in the numerator. Simple as that.
Like, can you like box like which one goes?
No, so with these, when you take this and move it here, you don't take the negative with
So like, what
you.
if there was like a nosebleed?
Well, then then you would move it to the bottom. But I actually have never really given anybody that one. I guess you could,
What if it was like a subtraction like on the bottom?
like a minus and negative,
I thought then you like.
because
So
then
then you
well,
put
then
it,
you
you
could
put it on
turn
the
it.
top, right?
Yeah, plus and then you put it at the top, which is what would happen anyways. Because if it was a minus and it went in the denominator and it was negative, you would put it to the top.
Can you box them?
Yeah, box the ones that go to get like the different terms. Oh, so yeah, this. like that. You want me to do that? That was there. This is there. This is not very clean. Sorry. This is right there, and this is right there.
All the ones that are negative pretty much go to the bottom, right?
All the ones that are negative essentially just go in the denominator.
Alright.
Keep it simple that way.
I think we need a brain break.
Oh man, we do brain breaks at our house. There's like a whole YouTube channel on it.
Yeah, we should do one.
It was that one like website. It's like I think it's like Go-Go or something.
Ready?
And they get like a little character and you're
Oh yeah. That's what my daughter does.
like, yeah.
And then they make them do like dance moves and like
Like the
quizzes.
show.
Yeah. I think that's good for today. I think you guys got all the information you need. All right, guys. So tomorrow